The broadcast is now starting. All attendees are in listen-only mode.
Hi everybody, thank you so much for joining our School on Wheels workshop today, Demystifying K-7 Math Common Core Standards. My name is Amanda Carr and I'm the trainer at School on Wheels, and I have with me today Kelsey Ritzel, who is one of our former tutors who will be hosting the workshop today. Just a few notes before we get started. For the purposes of sound quality, all participants are currently muted. You have the ability to ask a question at any time using the question pane, so simply type in the question and press send. We'll choose the order of questions and read them out loud. You may also wish to use the headphones for better sound. So Kelsey Ritzel is the Associate Director of the High Road School in Norwalk, Connecticut, which is a nonprofit special education school for children with emotional and learning disabilities. Prior to moving to New York, Kelsey worked as an elementary and middle school special education teacher in Los Angeles and Baltimore. While living in LA, Kelsey volunteered as a tutor at School on Wheels, and she also gave us a workshop that's now available on our website. So this is her second workshop with us. She earned her MA in teaching from Notre Dame University of Maryland University with a dual certification in elementary education and special education. So thank you very much, Kelsey, for being here with us today. I'm going to turn it over to you.
Okay, thank you, Amanda, for that introduction. All right, so like Amanda said, this is my second workshop on Common Core Standards. Hopefully you had a chance to check out the first one. The first workshop really kind of gave some more detail as far as the background of the Common Core and kind of a more broad overview. Today I hope to go into some more depth with some of the math standards. I know a lot of you have had a lot of trouble with the math standards because the concepts are being taught in a much different way than they were when we were in school. So hopefully I can give you guys some good ideas and some things that you can use in your tutoring sessions. Okay, so just what we're going to go over today, just an overview of what we're going to cover. I am going to do a very brief overview of the Common Core State Standards, give you a little bit of history. We're also going to go through a brief organization of the Common Core State Standards, look at how they are organized and how they progress and build on one another. We're going to look at the Common Core State Standards in 6th and 7th grades, and then we're going to go into a little more detail in the three domains of operations and algebraic thinking, number and operations in base 10, and number and operations fractions. At the end, I do have a slide with some resources, and then hopefully we will have some time to answer any questions that you guys might have. I know there is a little chat feature, so throughout the presentation, if you do have questions and you would like to type them into that chat box, we can use those at the end. Okay, so why Common Core? If you saw the previous presentation, you did get a little more information on this. Common Core development began in 2009, and it basically began kind of as a result of our country being behind in educational standards, specifically in the areas of math and language arts. And so these standards were created by educators and other professionals in the education field to really help our students build 21st century skills and to really help them to be, global competitors in education. So California adopted the Common Core Standards in 2010 with the intent of full implementation in the 2014-2015 school year. So that's why a lot of you guys are now seeing all of these Common Core worksheets and homework come home, because it was just implemented last year. And the way that California did it, from my experience as a teacher with Los Angeles Unified, is that they taught a very small group of teachers and administrators kind of, the basics of Common Core, and then those teachers and administrators went out and taught the rest of their schools. So the reason that you're probably seeing a lot of disparities between different schools and different classrooms is because there was not one training for all of the teachers. Things have been varied from school to school and from district to district. Common Core State Standards were also developed as a nationwide, education program. So the thought is that no matter where you are in the country, the students are learning the exact same thing. Prior to these standards, each state had their own standards. So if you went from state to state, what the students were learning and how they were learning it varied. There is a focus on college and career readiness with the Common Core, and again, that's really those 21st century skills. Are students prepared for the rigor of college courses, or are they prepared for careers in the 21st century? There's also a focus with the Common Core on depth versus breadth. So the state standards that we had prior to Common Core focused on a ton of things, and they didn't spend a lot of time on each topic. So math is a perfect example. You might be teaching addition, and you might teach addition, one way for maybe 2 to 3 days, and then the next day you're working on subtraction, and you're just kind of plowing right along. And then at the end there'd be a test. So whether or not the students got it the first time, you didn't have time to check because you had to move on to the next topic. There were so many things to cover. So the Common Core has really condensed a lot of those things. They've broken it down and broken it up into the grade levels so that we get more in depth with specific skills. So that's why I'm sure you guys have seen there are 10 different ways to add two-digit numbers not using the standard algorithm. So we're using a lot of different a lot of different ways to teach the same topic. If you want some more information, achievethecore.org is a fantastic resource. That is where pretty much like the official Common Core website. So all of the standards are there, as well as the history and resources and other things. So that's a great place to go for more information. So the way the standards are organized, I just kind of created this little graphic to give you a better understanding. So there are two basic categories of standards under the math for Common Core. Our umbrella right here is the standards for mathematical practice. So those are our overarching standards that are the same for all students. Our raindrops here are domain standards, and those domain standards are specific for each grade level. The standards for mathematical practice, which are like our umbrella, they are overarching standards for all grade levels. They are not content-based, rather they are how students should learn and think. So these are showing our teachers how they should be teaching our students, as well as helping our students learn how to think critically and to solve problems. So there are 8 standards for mathematical practice, and again, these are the same whether you're in kindergarten or you're in high school. The first is to make sense of problems and persevere in solving them. So that means that students are finding the meaning in problems, they're analyzing and planning solutions, they're monitoring their solutions and adjusting if necessary, they're verifying their answers. The second is to reason abstractly and quantitatively. So students are making sense of quantities and their relationships and problems, they're contextualizing and decontextualizing problems, and they're creating coherent representations of problems, so showing their work with pictures or with objects. Number 3 is to construct viable arguments and critique the reasoning of others. So this is in problem solving. Students can understand and use information to construct arguments. They can make and explore the truth of conjectures. They can recognize and use counterexamples. And then they can justify their conclusions and respond to the arguments of others. So they're able to not only defend their answers to a problem, but they're also able to look at somebody else's answers and determine whether or not it's reasonable and find the mistakes. Number 4 is to model with mathematics. So this is to apply mathematics to problems in everyday life. They're making assumptions and approximations, identifying quantities in a practical situation. So you're looking more at how does this relate to my life? We're giving meaning to the mathematics. Number 5, use appropriate tools strategically. So this is when we're using tools such as, it could be as simple as a paper and pencil, it could be a concrete model, a ruler, a protractor, Manipulatives like the base 10 blocks. It could be something that they're using on the computer. But the students are able to make sound decisions as to which of those might be helpful and then use those to solve the problems. Number 6 is attend to precision. So students are able to communicate precisely to others. They're able to use clear definitions, state the meaning of symbols, and be careful about specifying units of measure. And they can calculate accurately and efficiently. There is a push in number and operations for fluency of math facts, and so that kind of goes right along with this attend to precision. Number 7 is to look for and make use of structure. So this standard focuses on a student's ability to discern patterns and structures. Students are able to step back and overview and look at their problem, maybe shift their perspective, see the solution from another student's point of view. And really break things down, break a problem down into its smaller parts to solve it. And number 8 is to look for and express regularity in repeated reasoning. So students can notice if calculations are repeated. They can look for general methods, use shortcuts. And they can also maintain oversight of the process while attending to detail. And again, they're going to be able to evaluate the reasonableness of their results. So is my answer reasonable for what I'm doing? Does it make sense? So those are our 8 standards for mathematical practice. Those are those overarching kind of umbrella standards that all students are learning. Moving on to our domain standards. So domain standards are linked across grade levels with skills building upon one another. So the domain standards are kind of like stairs. So what you learn in kindergarten is going to build on what you learn in first grade to second to third. They are kind of linked. So you can see from this graphic, counting and cardinality is only taught in kindergarten, whereas operations and algebraic thinking, number and operations in base 10, and measurement and data are taught from K through 5th grade. Fractions begins in 3rd grade. Geometry is taught from kindergarten through 8th grade. And you can see right here between 5th and 6th grades there is definitely a divide where our elementary standards stop and then our middle school standards begin. So in the 6th, 7th, and 8th grade, we're going more into ratios, proportional relationships, functions, expressions, number system, statistics, and probability. So you can see how these kind of, cover most grade levels. So to kind of further that graphic or that visualization of the stair steps, we're going to take a look at some progressions in Math Content Standard 1. So this is with numbers and operations. And this is just the first standard. So we're looking at the first standard for kindergarten, 1st and 2nd grade. So you can see in kindergarteners should be able to represent addition and subtraction with objects, fingers, mental images, drawings, sounds, acting out situations, verbal explanations, expressions, or equations. So we're representing those addition and subtraction problems. You can see in kindergarten, there is quite a focus on using objects, using drawings, using different kind of manipulatives and getting them involved in the addition and subtraction. In the 1st grade, we're going to take that standard up a notch. Students should be able to use addition and subtraction within 20. So we went from representing to using. And we also have this parameter of within 20. So we're using addition and subtraction within 20 to solve word problems involving situations of adding to, taking from, putting together, taking apart, and comparing with unknowns in all positions. Using objects, drawings, and equations with a symbol for the unknown number to represent the problem. So this is just kind of a fancy way of saying that students will be able to add and subtract within 20 and using the equations, like 8 plus 10 equals 18. These unknowns right here are really laying the foundation for algebra, because in algebra, we're solving for an unknown. So they are laying that foundation even as early as 1st grade to say that, 8 plus what equals 18. So we're looking at the unknown in different positions. We're going to further this same standard in the second grade. So now instead of adding and subtracting within 20, students can add and subtract within 100. Right here we are just solving word problems. In the second grade we're solving 1- and 2-step word problems. So again, we're just kind of taking it up a notch. They should have a very good foundation, a very good base from the first grade to be able to build upon what they are learning in the second grade. So again, same kind of situations as it is here. So adding to, taking from, putting together, taking apart, comparing, unknowns in all positions. So those are the same. This one we're using drawings and equations with a symbol for the unknown number to represent the problem, which is exactly the same as up here. You'll notice that the only difference is that in the second grade they're only using drawings and equations, whereas in the first grade they could use objects, drawings, or equations. So here we're getting away from the concrete and we're getting more into the abstract. So kindergarten is very concrete, a little less so, and then here we're looking more towards the abstract. Now this is the same standard, the numbers and operations and algebraic thinking, math content standard 1. This one is for 3rd, 4th, and 5th grade. So you can see that, by the 3rd grade, we are no longer adding and subtracting within 100. We are now interpreting products of whole numbers. So 5 times 7 is the total number of objects and 5 groups of 7 objects. So 3rd grade is where we really have that switch from addition and subtraction to multiplication. 3rd graders are definitely still working on addition and subtraction, especially multi-digit addition and subtraction. But as far as the content standard goes, they're switching from addition and subtraction to multiplication. So again, you can kind of see how they build. So 3rd grade, we're interpreting products of whole numbers. In 4th grade, In 4th grade, we're interpreting a multiplication equation as a comparison. So 35 equals 5 times 7. Really means that 35 is 5 times as many as 7, 7 times as many as 5. So you're getting a little bit more into the depth of multiplication in 4th grade. And by the 5th grade, students should be able to use parentheses, brackets, or braces in numerical expressions and evaluate expressions with these symbols. So again, we're still working with that multiplication, but now instead of the typical X, we're using the parentheses, the brackets, or the braces. So again, that was just kind of to show you that the standards build upon one another and how they're related from grade to grade. So a Common Core in 6th and 7th grade. I'm just going to give you a very brief overview. Unfortunately, my experience is mostly in elementary education, and so 6th and 7th grade are not, I can't claim to be an expert in the Common Core state standards for 6th and 7th grade. But like you saw in that graphic, between 5th and 6th grade is really when the standards change. So we're getting more in depth into ratios, proportional relationships, expressions, and equations. The foundations of which for expressions and equations, these foundations were laid, you saw even as early as kindergarten and 1st grade, where they're using equations to show their addition and subtraction problems. The number system, statistics and probability, and geometry, those are the 5 main standards that are being taught in the 6th and 7th grade. With the students that you guys are working with School on Wheels, I feel like those students are most likely to need practice with foundational skills just because of, truancy or missing school, being a little bit behind. So we are going to focus more on those foundational skills today. If you do have specific questions about the Common Core in the 6th and 7th grade, or if you have specific questions about activities that you can do, you can definitely feel free to reach out and ask a question. I might have to do some research and get back to you, but I would be happy, to help with those 6th and 7th grade questions. So just keep that in mind if you are working with a student in middle school, maybe you need to, help them with a math assignment, you're not really sure, feel free to reach out. I'd be happy to help. Okay, so we're going to go right into the first standard, which is operations and algebraic thinking. Operations and algebraic thinking. This domain standard is taught in kindergarten through 5th grade. And this standard really focuses on the foundational skills for algebra. So like we saw in that standard, using unknowns for numbers, manipulating numbers in equations, and it also focuses on fluency in the 4 operations. So fluency is the ability to do something quickly and with accuracy. In this case, it is the 4 operations: addition, subtraction, multiplication, and division. So you might see some things that look like this in helping your students. The first one is a number bond. Used to be known as a fact family or a fact triangle. But basically, this is just teaching the students the relationship between addition and subtraction. So you have 3 numbers, 5, 3, and 8, and it's showing the students that 5 plus 3 equals 8, 3 plus 5 equals 8, 8 minus 5 is 3. So it's showing them the relationship between addition and subtraction, as well as really teaching them kind of those properties that, it doesn't matter in which order your numbers are. 5 plus 3 equals 8, 3 plus 5 equals 8, it's all the same. A tape diagram, which is right down here, is another one that you might see. In fact, I do remember seeing it when I was working with some of the students. And this is just another way to represent addition and subtraction. And so the tape diagram will show you, this one is an example of 2 plus 3 plus 7 equals what? We're using that question mark right now. Again, remember this is algebraic thinking, so we're getting into the basics of algebra. If this were algebra, we might use an X or a letter right here, but since this is the basics, we're using a question mark. The tape diagram serves 2 purposes. One is that it's a way for students to represent the numbers that they need to add, but not necessarily use a standard algorithm. It also serves to show how big the numbers are in relation to each other. So you'll see on this one we've got 2, which is the smallest, plus 3, which is in the middle, plus 7, which is much larger than either one of them. So we're giving a visual representation to the numbers so that students have a better understanding of the value of each number. This could also be used for subtraction. In a subtraction problem, you would have the answer up here where the question mark is, and then you might have a blank where one of these numbers is. Again, they're kind of manipulating the numbers and using their problem-solving skills. This over here is a tens frame. This tens frame you're going to see most often in kindergarten and 1st grade. The tens frame is used to help kindergarten and 1st graders gain fluency in adding sums up to 10. So basically what it does is that it's 10 boxes. And students are taught that it is 10 boxes, and so they should know automatically that this whole thing right here equals 10. And then different kind of counters are put into the tens frame. So this one might be 6 plus what number equals 10. Students can use counters, or they can count the boxes to show that 6 plus 4 equals 10. So again, just like the tape diagram, we're giving a visual representation to our addition problems. Similarly, this could also be used for subtraction. You might start with a full tens frame and take away 4 and say 10 take away or minus 4 equals what? And students can then count the remaining counters. There is a really good video when we get to our resources page. There's a great video of a teacher teaching her students how to use the tens frame in kindergarten and getting them to explain their answers. That's going back to those standards for mathematical practice, having the students explain, well, how did you know that 6 plus 4 equaled 10? What did you do to solve that? Finally, getting down here into multiplication, Another way that students are being taught for multiplication is by using arrays. So an array is basically just groups of similar objects. So just like multiplication are equal groups, here we've got 4 times 3 equals 12. We've got 4 groups of 3. This is another visual representation for a mathematical concept. All right, so activities that you guys can use with your students to help them gain fluency in operations and algebraic thinking. Flashcards are fast, simple, easy. Those are always something that you can either have on hand or make very quickly to use with your students. Because a big part of these standards, like I said before, is fluency in the 4 operations. So being able to add, subtract, multiply, and divide quickly and accurately. Dice games are also another very easy thing that you can use with your kids, as long as you're able to steal a couple of dice from a board game. You can take turns rolling the dice and then either adding, subtracting, or multiplying the 2 numbers that come up on top. With the littler ones, the dice game is also a really good way to teach them more than or less than. So you might roll the 2 dice and see which number is bigger. War is another great game if you just have a deck of cards around. Again, with the dice game, you can use war to teach students greater than or less than. So they might be, flipping over your cards just like you would in a regular game of war where you split the deck in half. And it might be whoever has the bigger number. You can kind of take that to the next level by making it a multiplication or an addition game. So just like it sounds, you would flip over your cards, you and your student, and then you would multiply or add the 2 numbers. If your student needs practice with foundational skills, you might just want to do that as practice. If your kids are motivated by competition, we usually make it whoever can do it the fastest gets to keep the cards, which as an adult you sometimes have to fudge it a little bit and purposefully lose. But that's okay. It gives the kids that boost of confidence. Getting into multiplication and getting into the foundations of multiplication, teaching kids skip counting is a fantastic way to help them with multiplication and with multiplication fluency. So the teaching channel, I have the link right here. If we send this out to you guys later, you'll be able to look it up. But the teaching channel is a fantastic resource, so I would definitely suggest that you check it out. This specific video is of a teacher who's doing a skip counting warm-up activity with her kids, and she has a CD on, which if you just YouTube skip counting, there are raps, there are hip-hop songs, there are like little kid songs for skip counting. There's a ton of resources. And this particular teacher on this teaching channel, she has the kids doing the Macarena, and I think they're skip counting by 3s. So for each number, they're doing a different move of the Macarena. So getting the kids moving and getting them doing that kinesthetic part is going to help them to remember the numbers. So movement is great. We used to just do different things. We would skip count in my classroom. Sometimes we'd do jumping jacks, and they would say, a different number for each time they jumped. Sometimes it was lunges, any kind of movement that you can get the kids doing to help them, link that movement with the number is very helpful. Songs, like I said, you can go on YouTube, and there are a million skip counting songs. You can also make them up. We used to sing 3s to the tune of Happy Birthday. Any little jingle like that, and that was great because then the kids would be taking a multiplication test and they all would be singing the Happy Birthday song under their breath while they were, figuring out their 3s. And finally, you can use cards. So you can either use flashcards, or you could very simply write the numbers. Say you're doing 2, so you do 2, 4, 6, 8, up to 20 on cards. Shuffle them all up, and then with your student, you can practice putting them in order. Same thing, you could do kind of a number line with missing numbers. The number line is also really great for skip counting. You can very easily just use a sentence strip, make a number line. It could be 1 to 20, 1 to 25, and then you can have your student use a different color for the different multiples. So for example, all of your 2s might be pink, your 3s might be blue, and then that will be a very valid tool for them to use. You could do colors, you could do shapes. We would like circle all the 2s, put a triangle around the 3s, things like that to help them practice. Because a big part of operations in the 3rd and 4th grade is being able to find factors and multiples. So the skip counting is going to help with multiplication. It's also going to help them with finding factors and multiples. Finally, this link down here at the bottom, mathwire.com. Mathwire.com is a fantastic resource to find games to practice the 4 operations. So these are very simple things that you can go on. There are a ton of ideas. Some of them are printable. Some of them are just, games that you can look at online. Some of them are links to online activities. But this is a really good resource and a really great website if you're just completely out of ideas and flashcards are boring and you've done everything else. There are a ton of different resources on mathwire.com. All right, so I know we had some questions about multiplication and how multiplication is being taught. It's being taught in a number of ways. One of the simplest ways is to teach multiplication as equal groups. So I always taught my students that our multiplication sign right here meant groups of. So I wouldn't say 5 times 3, I would say 5 groups of 3. So what we would do is you'd say 5 groups. So I'm going to make my 5 groups. You can very simply just have your student, draw 5 circles or however many circles it's going to be. And then because they are groups of 3, I'm going to put 3 in each of these circles. To find the answer, you're simply going to just count all of them in here. So that's one way, is to just do equal groups and to have your student draw the number of groups and then put the number of tallies or dots or stars, whatever representation they want to use. Or if your kid is more hands-on, you can have them use manipulatives. It could be something as simple as like dried beans or macaroni. Or if you actually have the little tiles or the little like cubes, it could be something like that. You can get creative with what you're putting in your groups. So 5 groups of 3. Multiplication at the foundational level with Common Core is also being taught as repeated addition. So students need to be able to know that 5 times 3 is the same as 3 plus 3 plus 3 plus 3 plus 3. Or alternatively, 5 plus 5 plus 5. So either of those strategies are really good foundational strategies along with the skip counting. 5 should be pretty easy. A lot of kids, are able to skip count by 2s and 5s. For some reason, those are the 2 that are the strongest with most students. So being able to skip count by 5s or write it out is another great way to help your students with multiplication. Division is very similar, it's just the opposite. So teaching your students that, if your students have really good foundation of multiplication skills, division will be much easier. So Common Core follows that rule as well. So multiplication is taught first. Students should be fluent with all of their multiplication facts by the end of 3rd grade. And that is really to help them with division. Division is also taught in 3rd grade, but later in the year. So we can do the same thing with division like we did with multiplication. In multiplication, we made our equal groups. We can do the same thing with division. So if your student came to you with this problem, you might see them work it out like this. We've got 15 divided by 3. So I know I have 3 groups, so I will make my 3 groups. And now what I'm going to do, instead of putting 15 in each group, which some of our students do get confused between the multiplication and the division strategies, I'm going to count up to 15. So basically you would just have, let me grab a marker right here. So basically, you would just have your student count up. So start here and read 1, 2, 3, 4, 5, 6. Count up to 15, and then they're just going to count the number in one group. So when we're dividing, we're looking for one group. So we start with our whole and we divide it out into our equal groups. Again, like I said before, if your students are really good with their multiplication skills, division, they can use a fact family to show 15 divided by 3 equals 5, but 5 times 3 equals 15. So they can use their multiplication facts to really help them figure out the division facts as well. Okay, moving on from operations and algebraic thinking, we're going into our second standard, which is numbers and operations in base 10. This, I think, is where a lot of people are having trouble, because this is our addition with multi-digit numbers, our subtraction with multi-digit numbers, and we were all taught to add and subtract this way, in my red box. So you're taught that 7 plus 3 is 10. I'm going to put my 1 up here, my 0 down here. All right, 7 plus 1 is 8, plus 5 is 13, 1 up here, 3 down here. And that was fine, and it worked. And I know a lot of people now are like, why are they teaching it all these different ways? I learned the algorithm, and it worked, and I can add. The reason that they are kind of taking a step back and not teaching the algorithm right away is that they want kids to understand what those numbers mean. So 7 plus 3, this is not a 1 up here. This is actually my 10, so I'm regrouping into my tens place. Same thing, this 7 plus 5, this is not just a 13. This is 100 that I'm regrouping over here, because this is 70 plus 50. So they were finding that kids were able to follow the steps. They knew to put the 1 up, keep going, put the 1 up. They could follow the steps, that they didn't know why. So Common Core is really hoping to give kids that why. Why am I doing this? Why am I putting the 1 up top and the 0 down here? So it's focusing more on place value. So you can see there's a couple examples down here. We'll do a couple more together. But down here, we're basically looking at our ones place. So I've got my 6 plus 8. And 6 plus 8 is 14. So instead of putting my 1 up here and my 4 down here, I'm just going to write the whole 14. After that, I'm looking into my tens place. So I've got 30 plus 40. This is not 3 plus 4. That's a common misunderstanding with our students. It is 30 plus 40 because it is in the tens place. So 30 plus 40 is 70. So now I can add the whole thing together. There is no regrouping, which is helpful for our students, because a lot of times that's where they make the mistakes. They are unable to regroup, and so they make the mistakes up here, and they forget the 1, or they put the 10 down here, and so this way there are no mistakes. 14 plus 70 is 84. The other cool thing with doing math this way is that you do not have to start on the right and move to the left. You can do it either way. So my second example right here is showing just that same property. You could do 30 plus 40 equals 70 first, and then move on to 6 plus 8 equals 14, and finally add them all together. You do not have to go from right to left. So over here, this is just one with 3-digit. So I've got, again, my 6 plus 8 is 14. I'm putting the whole thing underneath of there. Moving to my tens place, 10 plus 20 is 30. And finally, 100 plus 100 is 200. I can easily add these numbers. No problem. There's no regrouping. There's no place to make a mistake. So that is kind of, the biggest change, I think, and the biggest thing that's been very difficult for a lot of people who learned how to add and subtract using the algorithm. The algorithm is introduced and it is taught, but it is not introduced until 3rd grade. So kindergarten, 1st, and 2nd grade, students are adding and subtracting based on place value, using a lot of models, using a lot of number lines, and a lot of manipulatives. I'm sure all of you are very familiar with this right up here. These are my base 10 blocks. So I've got my hundreds, my big square flats, I've got my tens, my rods, and then my ones are my little squares over here. And a lot of times these are used. I'm going to show you in the next slide how to add and subtract using these base 10 blocks. If you do not have base 10 blocks, students should be taught, they should know that you can just draw a square, a line, and a dot. Okay, so we're just going to go over an example for place value based addition. So I have my problem here, 67 plus 85. I could do this in two ways. I could either do it in the first way where I'm adding my ones and then adding my tens, or I could do it using a model. I'm going to show you both ways today, just so that you have a feel and you can use this strategy with your students. So the first thing I'm going to do is the place value model without using the base 10 blocks. So I'm first going to add my ones. So I've got 7 plus 5. And 7 plus 5 equals 12. I can either put the entire 12, or if you really wanted to, you could write it out 10 plus 2. Use a different color for my tens. I'm then going to move over here to my tens. I've got 80 and 60. So I'm going to go ahead and add 80 plus 60, which is going to be 140. Now I can add my 140 plus 12. At this time, if you wanted to put it up and down to make it easier to visualize, 0 plus 2 is 2, 4 plus 1 is 5, and my 100. So that's just how you can do it using place value. So add the ones, add the tens, there's no regrouping, and we're trying to make this as simple as possible. If I wanted to do the same thing using my place value blocks or my base 10 blocks, I would simply represent each number in base 10. So I'll start with 67. So 67 is going to be 6 tens. 1, and 7 ones. Oops, I apologize. Okay. My 85 is going to be 8 tens. And 5 ones. Now I'm looking for groups of 10. Because in our base 10 model, when students are taught about base 10, they know that 10 ones equals 110, 10 tens equals 100. So now I'm going to be looking for groups of 10. And I'm going to start in my ones place and find a group of 10. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to circle these 10. And I know that these 10 ones are going to equal 110. So I'm going to go ahead and add another 10 over here in my tens place. Now I'm left over here with 2 ones. That's fine. I cannot make those into a 10. So I'm going to do the same thing with my tens. I'm looking for groups of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to make a group. And these 10 tens are going to equal 100. I should have made ourselves a little hundreds column. But I'll just go over here and make myself a square. That's my flat 100. And I'm left with 1, 2, 3, 4, 5 tens. Again, I cannot regroup these into another 10, so here's my 5. And I have 100. I get the same number, 152. So either way, whether you're making a representation to show the regrouping, you are still regrouping with this one, but it's more visual and more hands-on. Or whether you're using this base 10 value, and base 10 model, I apologize, same kind of thing. So now we're going to do the same thing using subtraction. So with subtraction, I'm just going to show you using the base 10 model with the blocks. In subtraction, I'm only going to show my first or my biggest number. So my biggest number, my greatest number in this equation is 85. So I'm going to represent 85 using tens and ones. So I've got 8 tens. And I have 5 ones. Okay. Now from these 8 tens and 5 ones, I'm taking away 67. So I look right here and I have a 7 in my ones place. So I'm going to come over here to my ones place and I don't have 7 over here. I'm unable to take away 7. So what I can do is I can come over here and I'm going to take one of my tens, cross it out, and this 110 is 10 ones, so I'm going to add 10 ones. So now instead of just having 5 ones, I now have 15 ones. So because I have 15 ones, I'm now able to take away 7. So I'm just going to take grab a different color so you can see it. And I'm just going to take away 7 ones. And I'm going to circle what I have left. It's a little messy. I got that guy in there, but we've got 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 ones left. Now I'm going to come over here to my tens. I need to take away 60 or 6 of my tens. So I already got rid of 1, so I'm going to get rid of 6 more. And I'm only left with 1. So I have my 110 down here. So my answer is 18. So that is how to use a place value or a based subtraction with your students. If you actually have the little base 10 rods or the place value rods, those are very helpful. But drawing a picture is just, as reasonable. So again, for subtraction, you just represent the largest number, and then you take away, if you don't have enough in your ones, you take away a 10, add 10 ones, and then subtract from there. These are a couple of videos that are on the teaching channel that I'm going to have this PowerPoint sent out to you guys. It's just another example of adding and subtracting with regrouping. Okay, so some activities you guys can do along with the addition and subtraction I just showed you to help your students in base 10. So this is really where we're helping our students gain a better understanding of place value. So one of my favorite things to do with my students is to have them make a decoder. So a decoder is very simple. You just get styrofoam cups, make sure they have a lip, and you put the numbers 0 through 9 around the outside ring of each cup. You then put your tens here, so each 1, 0, and then your hundreds, so 2 zeros, and so on as far up as you want to go. You push all of these cups together, have the student dial the number, so they're going to line up the numbers on the lip, and then you can pull it apart. And so this really helps with expanded form, and it really helps the students learn about place value. So this 524,971, this 9 is actually 900, not just 9. Same thing, this is 20,000, not just 2. So that's a really fun project to make with your kids. Again, we're bringing out back the dice or the number cards. They're always handy. You can have your students do higher or lower. You can play some other dice games with a game board that looks like this. So it is place value, thousands, hundreds, tens, ones. And you simply roll the dice Or the same thing, you could use the number cards, and you're going to be in competition with your student, or with, the students can compete against each other to either make the highest number or make the lowest number. And so, for example, if you rolled a 6 and you're trying to make the largest number, they would need to know that you would want to put that 6 in the thousands place, because that's going to make your number so much bigger, versus wanting to put that 6 in the ones place, because that's not the largest place. And finally, when all else fails, you can use money. Our kids love money. They love working with money. And you can use those as a manipulative to teach base 10. So here we have it with the decimal point. So we're using our $1 bills as our ones. We're using our dimes as our tenths, and our pennies as our hundredths. And this is also great to show that a penny is 1/100th of a dollar. Same thing, a dime is 1/10th of a dollar. So we're working in those fractions as well. If you did not want to get into coins and decimals, you could simply use $1 bills, $10 bills, and $100 bills and have them add and subtract using that money. We're pulling in those real world examples. All right, and the final standard that we're going to look at today is number and operations fractions. So fractions are introduced in the 3rd grade, and fractions are a pretty difficult concept for students to grasp at first. And so there's a lot of focus on a basic understanding of what fractions are, and there's a lot of focus on fractions on number lines and making representations of fractions. So you'll see, just like I said, fraction on number lines, and then we're also going to see these tape diagrams again to visualize fractions. So students are practicing splitting either a tape diagram or a number line into an equal number of pieces based on the denominator, and then you can compare using the visualization. Some really great activities that you can do with your students. Fraction bingo is fantastic. I think there are printable versions online you can print. And basically what it is that the card has the visual representations, and then the little bingo cards that you would pull have the fraction. So the students are matching up the fraction with the visualization. Fractions on a number line, you can help your student. You do something like this where it's color-coded. I've got my halves in green, my fourths in blue, my eighths in red, and again, this is going to help with equivalent fractions because you can see how many jumps it takes for each one. Equivalent fractions is also great to teach with this foldable. So you can look up the directions for this foldable online. It's very simple. And basically you're just having them break each of these kind of flaps down into the fractions. And this is a great way to show them equivalency. Fraction memory is a very easy game to make. You can use just index cards, or you could probably find this online to print. Basically, you're going to have a visual representation of a fraction on one card and the actual fraction, the numerical fraction, on another card, and you're just playing memory to see if you can match them. Finally, my favorite activity to do to teach children fractions and the foundations of fractions is to use candy fractions. So either Skittles or M&Ms are fantastic. You open up a pack of Skittles or M&Ms, you count the total, and then you separate them by color, and then you can see what fraction of each one of the total is each color. All right, so some quick resources. I'm running out of time here, but we'll go quickly. I didn't put a ton of resources on here just because the School on Wheels website, when I was checking it out and going through, has so many Common Core resources and tutoring resources that I didn't want to just replicate exactly what they already have on their website. So the School on Wheels academic program is a new program. I'm sure you guys have heard a little bit about it, where you can assess your students to see where their weaknesses are, and then there are specific resources online to help with those weaknesses. So that's a really cool program, something that you guys, if you're not sure where to start with your student, it's always a good idea to kind of get that baseline data. AchieveTheCore.org has a lot of great Common Core resources, as does CoreStandards.org. The California Department of Education will give you some more information as to how standards are being implemented in California. Learn with Math Games is a fantastic place to go get some some games and some things, some activities, hands-on things you can do with your students. And finally, the teaching channel. There are videos of teachers teaching Common Core-based standards in their classrooms. So if you're ever not sure how to do something and you have something that you're, kind of stumped on, you can go to the teaching channel, and it's not just for you, but if it's a skill that you're uncomfortable with, you can show those videos to your students. And it can be a learning experience for both of you. And the final resource, which I did not put on here, but which I would highly suggest using, are your students. Ask them how they learned that skill that day. Ask them what their teacher taught them. How did you do it in class? If a student is able to explain to you how they were taught that skill, and they're able to explain to you their thinking and how they could come up with a solution, and kind of they get a chance to be the teacher, they're not only taking control of their learning, but they're also solidifying those skills. So any student who's able to tell you how they learned it in class, that's just another great way to help them to remember those steps and to solidify that skill. So that is all for now. Unfortunately, I'm sorry, we only have a couple of minutes for questions. I know that both Natasha and Amanda have my email address, so if there's anything that I can help with, feel free to email me as well.
Great.
Did we have any questions?
We do actually have one question from Maria.
Okay.
We have a couple coming in. So the first question is, in general, about the standards, have they been raised, especially for the lower levels for Common Core?
Yeah, so actually the standards for Common Core are, the buzzword around the standards is rigorous. They're full of rigor. So that is definitely a very, something that has been brought up before. These standards are expecting students to do more, and that is why the standards build upon each other, because what you need to learn in first grade is so much more, than what we used to teach and what the students used to learn. So they are expecting the students to do much more higher level thinking skills at an earlier age.
Great, thank you so much. We have a question about long division and how it's done, and that's from Jean. Jean, we're going to send you an example of how long division is done. I don't think we have time to do that right now because we only have a couple minutes, but that is a great question, and we will see what we can drum up for you, Jean. Another question from Allison. Can we utilize the slides as a template for posters to be used at group tutoring sessions?
My slides? Sure.
Yes. Absolutely.
Of course.
Okay, great. Thank you. Yeah, I think that they were all fabulous, and there's so many really fun activities to do with students. I think sometimes we just end up doing worksheets, but making it hands-on, and even with older students that are still learning the basics, I think is really useful. We probably have. Okay, great. Oh, Maria wants to know about the long division info, so we'll send that to her as well. Perfect. Anybody else have any other questions before we stop for today? I think maybe not. So if you do have any questions, attendees, please do email them to myself. I can pass them on to Kelsey, and we can find you the answers at School on Wheels too. And yes, so thank you very much, everybody who attended. I really appreciate that. It was great. It was a wonderful session. Kelsey, thank you so much for spending some time with us today, all the way from the East Coast. We really do appreciate that. Awesome.
Thanks for having me.
Great. Well, we'll just end that right now, and everybody have a happy holiday. We will see you in January.